Okay, chapter 5.1, identifying similar figures. Okay, now this is interesting. We talk about similar figures. These two figures are similar. They have what are called corresponding angles and corresponding sides. So we're looking for corresponding I had to check to see corresponding. It has two R's. So we have corresponding angles and corresponding sides. Okay, so one of the neat things here is the way that they do this when they if they put a single circle or an arc on one triangle, you can find the single arc on the other triangle, and you recognize the fact that those are equivalent. Angle A is equal to angle B, and that's written like this. I almost wrote a B. Angle A is equal or congruent to angle D. Okay, and we can see that when they have two arcs, those two angles are congruent. So we would see that angle B is congruent or equal to angle E. And the same thing where there are three arcs. Angle C is equal to angle F. Now this is an angle symbol. This little, it's kind of a less than sign, but it's also an angle symbol. I guess technically it's written with the bottom edge flat and the top edge angled, or level and angled. Corresponding angles are kind of like these equal angles. These triangles are similar if the shapes are the same shape but not the same size. So we're talking about similar. They are similar if they're the same shape, but it has to be exactly the same shape. So for instance, maybe I should use a straight line here. This triangle isn't going to be perfect, but it's relatively similar to this triangle. These two go together, these two go together, and these two go together. And the angles are the same, or they're supposed to be. The sides might be a little different. Each side here is a little longer than the corresponding side. But if I were to draw this triangle, it is not similar. Even though it is still a triangle, it is not the same exact shape as these two. So this one doesn't work. I could draw this one upside down, and I could still say that this is similar to these ones. It's just flipped over and moved around a little bit. It's similar. But if I draw something crazy that has completely different angles, it is not similar. So similar has the same shape, but not exactly the same size. Like if I have a square, it is similar to another square, well, it's not similar to that square. It's similar to another square that has the same shape, but a slightly different size. But it's not going to be similar to a rectangle that is actually a different shape. So it has to be, the angles have to be congruent, and the sides have to be all in the same ratio. We have been talking about ratios. Alright, so I am going to delete this, and we'll try again naming our corresponding angles and sides. It's going to ask you to name corresponding angles. So for corresponding angles, we would mark it down like angle A and angle D. That's all you have to do, but you got to mark all of them. Angle B and angle E, angle C, and angle F. And for the sides, we're going to mark those a little differently. We're going to say side AB. The book says side AB, like this, and then they write and. This is AB, this one is DE. But I'm going to go ahead and just mark it with the line segment, with a little line above it, because I don't have to write side every time. So then BC would be corresponding to EF. And this is how you write it. And AC or CA, you can write it either way, is corresponding to DF. And there's some interesting things you can see. Notice that 20 is twice as much as 10, and that 12 is twice as much as 6, and 14 is twice as much as 7. So this triangle has lengths that are twice as big. And that's just interesting. It helps us to understand that it is corresponding, even if we didn't know that the angles were, because the sides are all the same. It gives us some information. So, and this works whether you're working with triangles, rectangles, trapezoids, octagons, any figure. They can be similar. In fact, you could draw a figure. Let's go ahead and erase this again. I guess I got close. There we go. You could draw an L-shaped figure, and it could be similar to a smaller L-shaped figure if everything were properly ratioed, etc. Okay, the next thing that they want you to do, to know how to do, okay, so here's a little picture from the book. This ought to help us. Oh, I don't want to make it smaller. I just want to move it over. Alright, so we're going to have to read it. Triangles, ABC is similar to triangle DEF, and this can be written, this is the symbology for how you do that. Triangle, this little line means similar. Sometimes we can see it with two of them, almost like an equal sign that's squiggly. Okay, so we're doing it just one way right now, and then the little, this is a little triangle symbol, obviously. Triangle ABC is similar to triangle DEF. That's how you would read that. And you've got ABC over here and DEF, and you can see that they have marked the angles in the same way. They're both similar if corresponding side lengths are proportional and corresponding angle lengths have the same measure. So the angles are congruent or equal, but the lengths are proportional. And remember that triangle we looked at before, one side was twice as big as another. It doesn't have to be twice, it could be anything. But all the other sides on the bigger triangle are going to be that amount bigger in a multiplication form. And we've been working on ratios, so we can make that work. So they have kind of AB, which is this line, over DE. So you could make it as a ratio. AB over DE is equal to some other length, but you have to make sure that you match them. So I used AB on the top from this triangle, so I need to use, like, say AC or BC. AC on the top over here, and then the corresponding length on the bottom, which would be DF. So these are equal, and then they also included this other one that's equal, and they're all congruent to each other. So if we knew what this one was and this one was, and we knew what this one was, we could find out what DF is, segment DF. Okay, so that's just how that works. Angle A has the same measurement as angle D. We already talked about that, and the sides are proportionate, so we can figure out how to do that. This will help us solve problems.